Hello, and welcome to another episode in our Amazon EKS workshop series. Today, I'm joined by Nirmal Mehta, one of the core maintainers on the EKS workshop. It's May the 4th, and hopefully we can help you navigate the galaxy of container orchestration like a Jedi Master. May the 4th
Ooh,
be with you. All right,
ooh, that's
Nirmal.
a good one. That's a good one. Hi, everyone. I'm Nirmal Mehta. I'm a principal specialist solution architect, and I'm here today to use the Force and my trusty lightsaber that I borrowed from my partner, Kristen, to cut through our EKS orchestration with observability and monitoring practices. Are you all
Yes,
ready to get started?
let's do it. I'm ready. Nirmal, I want to start with let's explain to our viewers, why is observability important?
Yeah, observability is critical. And it's critical to all of us that are operating ECAS environments. It's critical to understanding what's going on. And it really is how we understand what the system is doing, what the performance is, and if it's doing what we want it to do, right? Is it meeting the business value that you want? Is it meeting the function and services that you need? And helps you make decisions about what to change or how to reconfigure or tune your EKS cluster. And there's no better way to describe the importance of observability than some quotes from our trusty crew of Star Wars characters. All right. So I'm going to let you guess which one of these amazing Star Wars cast of characters is pronouncing their advice and wisdom around observability. So the first one is Kubernetes observability. I'm not going to do the voices. I'm horrible at the voices.
I mean, you have to start it. All right.
Kubernetes observability, a crucial matter it is. Understand the flow of the force in your system, you must. To the dark side of downtime, ignorance can lead. Pay attention, you must. Clear your mind of foggy metrics and see clearly the path to stability and success. You will.
Okay, I have to know this one. It's obviously Yoda, and I'm going to one up you actually with the Yoda joke that I prepared for this. How does Yoda debug a Kubernetes cluster?
Ooh, how?
With the kubectl -- force command.
Ah,
There you
that's a
go.
good one. That's a good one.
All right.
All
So
right,
1 for
we'll
1 so
try
far.
one more. Should we go
Let's
for
do
one more?
it.
All right. Open telemetry is a powerful ally in our battle against the dark side of system complexity. With its ability to capture and analyze distributed traces, metrics, and logs, we can gain a greater understanding of the inner workings of our system. As with the Force, we must learn to wield open telemetry with care and precision. Only then can we hope to achieve true observability and keep our systems in balance.
Amazing. That one's got to be Obi-Wan Kenobi, right?
Yes, the Jedi teacher and master, and someone that we should probably all follow his advice to make sure that we don't land on the dark side of not understanding what's going on in our systems.
Exactly. And at the end of the day, that's the essence of observability. You're getting access into a system, you're getting a view into a running system. And so it's critical that you have the right tools for not only collecting that data, but also understanding it, displaying it, securing it, and all of the above. And today, we're going to be diving right in to the EKS
Yes.
workshop. Nirmal is the lead for the observability modules in the EKS workshop. So, Nirmal, I'm guessing you've been through this content through and through. So we're going to have you as our SME today, going through each one of these modules for our viewers here. Let's go ahead and get started.
Sounds awesome. Let's dig in. So, what I have open here is the observability module of the eksworkshop.com. So, today you can go along with me today, going through all the different modules. You can do it at your own pace, but I highly recommend checking it out to get a fundamental understanding of the overall observability picture that EKS can provide for you and the different services that we provide for observability and monitoring. So we're going to start off with just going right into the EKS console view, digging into some of the resources that you can see just right through the EKS console. Then we're going to step into one of the first steps around monitoring and observability, which is looking at logs, right? So oftentimes, once you get a cluster environment up and running, you've got some workloads deployed, you want to know what's going on. How are your workloads doing? What are the log statements coming from them to debug or to make sure that things are running properly? So we're going to dig into the logging, both on the control plane side and the workload side. So after the logging, we're going to jump into the two different styles of services that we have for monitoring observability. One side, we have the open source observability suite, where we're going to show AMP, AWS Managed Service from Prometheus, and the AWS distro for Open Telemetry collector running on the collector running on the cluster, and looking at some Grafana dashboards. And then we're going to switch to the AWS native observability suite around CloudWatch and container insights and dig into the containers or the cluster and the pods and services that are running on the cluster. So give you different views of observability services and so you can see which one you want to use in your own environment. And then finally, we're going to jump into KubeCost, which is a tool that allows you to look at the utilization and the cost of your workloads on the cluster and dig into that a little bit. Right now, performance and utilization optimization is top of mind for a lot of customers and users. Let's just start off the bat. We've got a cluster up and running. This is not an intro to the EKS workshop. That's in a previous video, and there might be a link somewhere at some point. Check that out. So we've already got a EKS cluster up and running. That's part of the workshop. And we have a workload running, which is this watch shop. If you go through the introduction and fundamentals steps of the workshop, you'll have that application up and running. So we have some data, we have some workloads running on the cluster. On top of that, I've got a special workload today that's running, and that's a full ASCII animation of one of the best Star Wars movies, New Hope. And that's running as a pod right now on the cluster. As you can see, we're kind of midway through the first act of A New Hope. So this is a pod that's running on my cluster right now, and we're going to dig in and see what the performance of it is, how it's working through the EKS console. Shall we?
Let's do it. I mean,
All
at
right.
the end of the day, I think maybe we covered this, but observability, I think it's such a buzzword these days. And when we look at the root of what it really is, it's the ability to measure the internal state of the system, any system,
Mhm.
by looking at its outputs, right? And
Correct.
so a lot of what we're going to be focusing on today is how do we measure the inputs and how do we visualize the outputs. And I believe the first module we're going to be running into is right in the Amazon AWS console. We're going to be looking right into a cluster and seeing the different, Kubernetes, not necessarily the YAML files or the manifests, but the resources that have been created for us.
Yeah, absolutely. And you're right. The idea behind observability is to have a holistic view of the system based on its outputs and the sensors that we have running in the system. So the first way to do that within EKS is to go right into the EKS console. There's a full set, as you can see, of steps in this lab. There's workloads, cluster, service, config. Just because of time today, we're not going to go through every single view, but I'm going to highlight some of the ones that someone would typically go into to start to get an understanding of the state of the system, of the cluster, and maybe even for some lightweight debugging of the system. So we've got this pod running right now. So let's step into the EKS console, and we can see here a few different tabs. One of the tabs here is resources. So we're going to click on resources, and this is where EKS console exposes the different resources, Kubernetes resources that are running on the cluster through the EKS console. So you can see here that there's different sections. There's workloads, the cluster. Let's expand some of these out. The cluster, services, config, storage, authentication, etc. Right? And we can go through these tabs and get more detail around those types of resources and really drill in. So let's try to find our Star Wars pod, if you will, and dig in just kind of start at the top. Most of the time, our workloads are deployed as deployments, right? And so a good place to start would be deployments. The default is to show all namespaces. And in our environment, we've got a bunch of namespaces. As you can see here, here's a namespace called Star Wars. That's probably of interest, right? So
Yeah.
let's take a look at that. And we can see that we have a, a single deployment called Star Wars. Super creative naming by myself. And we can quickly see, this is the really awesome part about the EKS console view. So we can quickly see what the status of it is. We got a nice status bar right here that says 1 ready, 0 failed, and 1 desired. As some of you might know, a deployment is a subset of or superset of replica sets, and replica sets dictate how many replicas of those pods should be running on the cluster at any given time. And for this deployment, it's just 1, and we can see that that 1 pod is running. Obviously, I showed the animation earlier, so it is running. So let's dig in.
In fact, I just want to point out, we actually have a dedicated video talking about deployments, replica sets, and pods, and I'll put that on the top left there, or the top right, rather, if you're interested in seeing more. One other comment that I wanted to bring up here, Nirmal, real quick, is that this view, it comes out of the box, right? So there's no collector or anything required. It's just using the Kubernetes API to retrieve this information and displaying it in the dashboard. And I think a key part of this is that it's a resource view, and it's just that, not letting you necessarily configure the resources in the console. It's just a representation of what's running in the cluster, right?
Absolutely, yeah. It's a read-only view at this time of the EKS cluster. And just a quick note, it's using the IAM user that you're logged into the console to authenticate into the cluster. So that user or that role needs to have the right RBAC permissions in the Kubernetes cluster for you to be able to see this information. As I set up this cluster using the same role that I'm logged into the AWS console, that's why I can see all this information. All right, so we clicked on the Star Wars deployment, and we can see that the image here, right? So if you want to check out this ASCII New Hope render, you can check out this Docker image. It's not an endorsement, but it's pretty cool. Check that out. So you can see the container image. You can see the selector. You can see the pods that are part of that deployment, any annotations. And one thing that's really awesome here is events. Anyone that spends any time with a Kubernetes cluster or an EKS cluster knows that events are kind of critical to the debugging flow. And it's where some of the information is with respect to if there's some issue with deploying that pod or that container or that service, etc. And so we can see here that an hour ago is when I deployed this pod or this deployment, and we can see that it worked out fine. And there's a replica set of 1, all good. We can see our annotations. Back to that, you kind of mentioned perhaps not being able to see the actual manifests. Well, there's a raw view here, which is, it's not quite the YAML, it's the JSON format of that resource, but it gives you all the information that Kubernetes has about that resource, right? So we can see here the status, but we can also see the spec, right? So this is the YAML manifest essentially, or the resource definition for this deployment.
Exactly. So if you were to get an object using the kubectl CLI -o JSON, you would see something very similar to that.
Yep.
So just again, a representation. This is a visual view of the Kubernetes API. And in many ways, I'd say it's similar to the open source Kubernetes dashboard as well, which, by the way, you can also deploy as an add-on to your EKS clusters. I just want to point that out.
Yeah, absolutely. And that's a great option as well. We're going to go into other views with the other tools later, but this is a quick way to kind of get an understanding of what's going on your cluster.
Nirmal, I would be remiss not to mention that even if your clusters are not running in AWS, say you have clusters outside of AWS, you can use the EKS connector to register them, and then actually see them and work with them in the same environment as you would your official Amazon EKS clusters.
Right. Just to put a finer point on that, EKS connector right now is for And just like the EKS console is a read-only view of the cluster at this time. But that's good enough for digging into what the current state is and what how the resources are defined. And yes, using EKS connector, you can connect in self-managed clusters, anything that EKS connector can run on, and then send data back to the AWS API.
Right. At the end of the day, it's any conformant Kubernetes cluster, and
Correct.
Amazon EKS is of course upstream conformant, and you can throw that connector into any conformant cluster and have it be represented here.
Yep. I just clicked on the pod while we were speaking here. Double clicking into the pod, we can see the status of this pod. We can see the pod IP. We can see what node it's running on. We can get information on the ports and the images, any mounts, environment variables, annotations, labels, etc. And of course, the events. Sometimes there's events around, let's say, a crash backoff loop, right? So something is wrong with the container and it's not, it's returning a error code, or it's exiting with a code 1 versus a code, just running. And you can dig into the events view here that I'm showing and see if there's a crash backoff loop from the deployment, or if it can't pull the container, etc.
Yeah.
All right.
A lot of folks, a lot of developers might be watching, thinking, "Look, I can do all this in the command line. Why would I ever need to use the console?" I can't tell you the number of times that people have told me that they've, on the road somewhere, out of the office or whatever, something goes wrong, and they quickly just pull up the console on their phone and click through to make sure things are up and running, or to find out what's going on. I think this is a great tool to do that. Just some quick and easy debugging when maybe you don't have the ability to pull up a terminal.
Correct. And having more options than just the terminal, that is always a good thing. Even as we understand our customers are using Kubernetes clusters for all types of different workloads and all types of services, right? So you might have folks deploying workloads, looking at the status of the cluster, that are not Kubernetes experts, right? And maybe they're data scientists or machine learning experts, and they need to understand the status of their workload. This is a great way to just give someone a read-only view into the status of the cluster, and so they can see their workloads and see what's going on. Another area that I want to kind of just highlight is the cluster view, so we can get an understanding of the nodes themselves. And this has links right to the managed node group definitions in the EKS console view. So you can click on the managed node group, or you can click on the node, and you can get a status of that node, right? So we can see here what the status of the node is, when it was created, the version, right? I know a bunch of us are going through version upgrades, right? Kubernetes moves fast, and might want to know what the version of a specific node is, what the instance type is. You can directly link right to the EC2 instance for a EC2 managed node. And you can also see this great capacity allocation view. So we can kind of see what's available for workloads, what's reserved for the system, what's available for additional workloads, and kind of just get a quick glance of the overall utilization of that specific node.
Yeah, honestly, I think this is probably one of the most important things for users that are administering clusters, because the fact is, for example, if you click that instance button right there, it launches straight into the EC2 compute dashboard, and now you're leveraging the over 10 years of console experience that we built in here, the networking, storage, security features that you're kind of clicking through here. All of that is available at your fingertips. So even though you're working with an EKS cluster, it's running on EC2, and you've got the ability to just switch over context and leverage all of that there.
Yep. Another resource that we oftentimes are interested in is on the network side, right? So you have services, ingresses. So I've got some services running here. We can click on the Star Wars service, and we can see that's a load balancer. We can even see the load balancer URL right here, which is super handy. I know a bunch of us have, and I think this is in the lab for the fundamentals section when we expose the application, but you have to run a command line to extract the DNS URL of your load balancer, for example, or an ALB. you can get it right here, right? And you just click right into it. The other part is config maps. There's lots of different config maps that are used all over the place within systems. One, I believe, there's some config maps around, let's say, Fluentbit. Yes. So here we can see a config map for the Fluentbit collector or the Fluentbit pod that's running. We'll be getting into the next section of this lab, but we can see the config map, which is the configuration of Fluentbit here. And so this is a very nice way to quickly see what the configuration of this tool is, look at the config maps that you have on the system, and make sure that it's matching what you expect it to match, right? And we'll be digging into this in just a little bit. And last, there's a lot of resources, and we can spend a lot of time just on digging into different resources. But the other one I want to call out is extension section here. And we have CRDs here, right? And a lot of times we run lots of different add-ons, custom controllers on our clusters. And that means that there's different types of CRDs. And so we can see a lot of CRDs here. I want to highlight one. That's the OpenTelemetry CRD. And so it's a nice way to get a read-only view into all the different types of CRDs, what versions are running, what CRs are deployed for that CRD, etc. So I hope I've shown you a little bit of a sampling of what's going on in this EKS cluster through the EKS console, and showed you that you can get a lot of information just right through the AWS console, and do a little bit of light debugging with the events and looking at the CRDs and other resources on the cluster.
Yeah, and I know a lot of folks that rely heavily on the console for debugging, and of course, not just these resource views, but of course, you could at the top click the Cloud Shell and then get access to your cluster and all of that. I like, Nirmal, that we're starting with the basics here, because now we're about to level up on the complexity and
Yes.
start getting into more interesting ways of extracting insights and analytics, metrics, telemetry from a given cluster. So let's get into it.
Yeah, absolutely. So the next level, if you will, of using the force with respect to the EKS cluster observability is logging. This is often the first step with the first type of telemetry that one collects within a cluster environment, and is a great way to just understand what's going on, right, across the whole entire cluster in terms of what's happening with the control plane, and also the workloads and other components of your cluster system. So the first part here in the lab is digging into the control plane logs. So I've already reset the environment, and want to just kind of highlight that when you use EKS Workshop, we enable all the control plane logs for that EKS cluster in this environment. So what does that mean? So of course, AWS runs and manages the control plane for you. And the control plane consists of different components. Those components provide log data, right? They expose log information continuously. And there's a few different components that are key to understanding what's going on in the control plane from a logging perspective. And those are highlighted right here. There's the Kubernetes API component logs. There's the audit log. There's the authenticator log. There's the controller manager log and the scheduler log. These are components that are critical to the function of a control plane, of course, and also critical for you to understand potentially what's going on the cluster and what you might need to dig into if you need to see what workloads or what services are running on a cluster are hitting the API server, what they're doing. And from an audit and authentication perspective, I know I've supported lots of customers in the past and currently that have regulation compliance rules that they have to follow, and they have to be able to prove who has access to the control plane, what the control plane is doing, be able to audit the control plane and the cluster itself. And so those logs are critical for getting that type of information. So like I mentioned, those logs are enabled. So let's see how you would enable those logs. So the first part is going to the AWS console, the EKS console, and clicking on logging, the logging tab. So luckily and nicely, we already have that up and run up here. So I'm going to click on this logging tab. So we have the EKS cluster right here, this EKS workshop, and we're going to click on logging. And we can see here is a list of all those components and those logs that I just mentioned, and whether they're on or not. So you can click on manage logs, and you can turn on whichever logs you want. So for example, maybe you only care about the API server logs, and you don't need to collect audit logs, authenticator, etc. You can only turn on the API server logs, for example, or any other component. So that's configurable and up to you to decide. In this case, we have them all turned on. So we're going to go back here into logging, and then we're going to check them out, shall we? So the first one we're going to check out is, or where do these logs go? You can actually click on, I believe you can click directly on this link, and it takes you right to the logs, which is really handy. So I clicked on the API server logs, and we can see here that all the control plane logs are under this log group, the path AWS/EKS. That's reserved for control plane logs. So you can't actually make this log group, it'll error out. And then we have the cluster name, and then we have cluster. Under there, we have log streams for the different components that we mentioned earlier. So right now I have the Kube API, the API server log stream up, and you can see the logs that we've collected for that component.
So Normal, I've got a question. I know a lot of our customers are using outside partner capabilities to visualize logs. Maybe they're using things like Datadog or a number of other solutions out there. So as I understand it, the control plane logs do need to flow through CloudWatch. But then how would you potentially take it to the next level and get them to a central place from CloudWatch?
That's a great question. I get that question all the time. I need to send my control plane logs to some other system, or I wanted them in S3. We actually have a blog post that describes a way to use Lambda and other services to take the logs from CloudWatch and send them to a destination of your choice. In the blog example, there's S3 as an endpoint for those logs, and then your third-party tool can grab them either directly from CloudWatch or from S3 or for some other service. We can link to that in this post description to that blog post. I would also say that stay tuned. There's going to be changes around how control plane logs are handled within EKS. So stay tuned to this channel, to AWS blogs, to the container EKS newsletter for when those changes occur sometime in the future to allow more flexibility with respect to the control plane logs.
Okay, and that blog, we will link it in the description below.
Yes, down there, I think. So let's dig into some logs just to kind of see what they look like. If there's one thing that Kubernetes is good for, it's creating log statements. So there's a lot of log information within just this API server stream. Let's just click on one right here. This was a request, and that was allowed for this specific reason. I just clicked on one random, so it might be something that we need to parse.
This one looks like it might be coming from the Open Telemetry collector, and
correct.
We'll probably see a ton of those logs because it's
correct.
always scraping and sending data, right?
Yeah, exactly. So we can see that this is the Open Telemetry collector that's hitting the API server for metadata that it adds to the metrics, and we'll be seeing that for sure in the next sections of this lab. But you can see that this log stream is collecting every single API, command that's sent to the API server, and every kind of response and the decisions that the API server is making with respect. Here's another one, kube state metrics, another component of observability. This is actually KubeCost's kube state metrics, collecting metadata from the API server to understand what's going on, the current status of the cluster, what's happening on the cluster. So
these logs are super crucial when something goes wrong and you have to go back and figure out what went wrong. One of my favorite things to do is read these super detailed postmortems that get posted regularly,
Hmm.
where something catastrophic happens and then some poor individual is sitting there diving through the logs to figure out exactly what happened, because without the logs you really can't figure out why things went wrong and potentially prevent it from happening again in the future. And here's really where that comes into play.
Yeah, and it is critical. I can't stress that enough. You do have a choice to turn these on or off when you're in a situation where you need to really dive deep into the operations and performance of your cluster, and you have a lot of tools that are hitting the API server, for example, or causing a lot of pod scheduling events, right? Maybe you're scheduling a ton of pods, right? Like hundreds, thousands of pods, and you want to know how those scheduling decisions are being made. And I would recommend turning some of these logs on to provide that detailed information that you can dig into to see what decisions are being made. So, for example, the scheduler, we can see if there's some events here. Let's see. Maybe the last hour when, yeah. So we can see I ran a collector configuration, and we can see that when I started up that collector, that this was the scheduler event, right? So it said that it successfully found a node for that a collector pod, and it evaluated 3 nodes. 2 of them were feasible, and it picked this node, right?
Mm.
Now, this is great. It's a successful scheduling of a pod. It's when things don't successfully get scheduled, or there's some other issue with how the nodes are evaluated, where digging into these logs will give you that information that you need to debug or to modify the system to meet your needs. Speaking of, CloudWatch has this awesome thing called CloudWatch Log Insights. And so we're going to dig into the next section of the lab where we do a little bit of not debugging, but a little bit of querying of the logs to get some information that is oftentimes useful for most of our customers to kind of understand. And that's around what services are hitting the API, or are requesting the API server, or doing connections to the API server to get specific data, right? So, and this is critical around observability, especially because a lot of observability tools, as is the nature of the sensor and the tool itself and the telemetry, is going to be connecting to like the kubelet or the control plane API server to get the metadata around those resources in order to label, annotate, filter, process that telemetry properly, so that when you're looking at it in a dashboard, you know, like, this is the CPU of this pod, or this is how many API server requests. So those tools that we have running, like the ADOT collector, are going to be requesting resources from the API server quite frequently. So let's see what the impact of that is, and see which ones are the noisiest components. So in this lab, we have the CloudWatch Log Insights section, and we're going to go right into Log Insights. So I'm going to click on this link, and that is going to pull up Log Insights. All right, and what we have here is the CloudWatch Log Insights query tool. And we're going to, by following these directions, we're going to pull up a specific log stream, which is the EKS workshop cluster control plane logs. So we have here is the log group, sorry, not log stream, but log group. So now we're looking in just those control plane logs. And we have a query here. Let's dig into this query really quickly. We are pulling the API server log stream, and we're going to look at the user agent, and we're going to sort and count some stats based on those user agents. So I'm going to copy this query, put this in, and run it against our control plane logs. There we go. So real quick, this is an awesome query because it's super simple to understand, and it gets you really good data. We have here is a list of all the user agents. So we can see the controller manager, We can see kube state metrics here. We've got, let's see what else. We've got the kubelet. We've got K8's metrics, Prometheus, a bunch of stuff. We've got so much stuff, Sai,
Yeah.
running on this workshop
Looks like no
cluster.
bad actors though, luckily. Like everything is relatively contained.
Correct. Yeah. As we can see here, the highest count is the controller manager, which makes sense, right? We can dig into here where we can see that the controller manager of this version, as it's doing its garbage collection function, right, is hitting the API server the most.
Of course.
And that makes sense.
In Kubernetes, everything is basically determined by this control loop, this ever-going loop of
Correct.
observing the state of what's in the cluster, matching it to the expected config, and then acting to resolve it. I'm not familiar with specifically the garbage collector piece, but I'm guessing when you run the same thing that many times, you'll need to clear out the memory once in a while.
Yes, absolutely. I just want to highlight, it looks like the top observability tool that we have running that is hitting the API server the most is Kube State Metrics, which makes total sense as well, right? So Kube State Metrics is a tool that provides Prometheus formatted metrics of the resources of your Kubernetes cluster, right? So how many pods are running, how many deployments you have, the status of all these resources that we dug into in the EKS console. That's what Kube State Metrics exposes. And of course, it's going to have to communicate to the API server to understand and create those metrics, right?
Okay, so we've talked about the resource view. We've talked about control plane logs.
Yep.
Now it looks like we're getting into the next piece and probably leveraging the first open source component of this particular section in the workshop, FluentBit. Tell us a little bit more about the importance of this next section.
Yeah, absolutely. So thank you for keeping me moving along and trucking here. So we've got pod logging. So pod logging, absolutely one of the first steps you should do when you're running a cluster in an environment. You're going to need to know what your container is doing, what your pod is doing.
Wait, Kubernetes already lets me get pod logs though, but okay, I can't tell you the number of times some pod crashes and I'm like, hey, wait, what happened again? And I have to go back and try to dig through and figure out or rerun the pod. So, okay, I'm with you here. All right.
Yeah, absolutely. And there's based on your configuration of your environment, there's a time limit to how long those logs are captured for an ephemeral workload. So it's a best practice. First of all, the first best practice is to use, the 12-factor app way of making sure that you're outputting your log statements both to standard out and standard error based on what you're doing, because the container runtime, which could be Docker or Containerd now, is capturing standard out and standard error, and it's writing it to a file, right? And that file is on that node that pod is running on. And that log file, there's no guarantees on how long that log file is going to sit on your node, what the buffer of it is, if it's going to capture everything necessarily. And so it's best practice to use another tool to take those log files and send them off of cluster or some other way to capture longer running log information. So that, like you said, if you've got ephemeral pods or you've got something's crashing and it's not there long enough for you to use the kubectl log command to get that log information, then you need to use a tool to dig into it. So the tool that we recommend, and that's part of this lab, is FluentBit. FluentBit is a CNCF upstream project. It's FluentD and FluentBit. And FluentBit is a high performance log aggregation, processing, and exporting tool, if you will. And in this lab, we're configuring it. We're going to be running it we have it running on the cluster, and we're going to look into the configuration of it. So AWS has a supported, just like ADOT, we have a supported version of FluentBit that's running in the EKS workshop environment. And we have a standard configuration of FluentBit to get the workload, the pod logs, and send them to CloudWatch.
Right.
So
So
let's,
one quick comment here. The key difference here with control plane logs, of course, you have to first get them into CloudWatch. That's where the control plane logs are forwarded by default. But with pod logging, of course, you have the benefit. You control the aggregation of the logs and where they're being forwarded. If you wanted to send them directly off your cluster to another, third-party monitoring service, you could do so. In
mhm,
this lab, we're showing how you can connect it up specifically to CloudWatch.
correct. Yeah. And FluentBit has a lot of configuration options. It's very flexible and it's very powerful too, in terms of filtering, processing, etc. And we'll go into that a little bit in this lab, but there's a lot of area to explore deeper on your own time. So first step here is, how are we deploying FluentBit? Well, like I mentioned, the container D is going to write the standard out, standard error of your container to a log file on the node. And so that means that FluentBit needs to run on all the nodes in that cluster. And so we have it deployed as a daemon set. As you can see, there's 2 nodes and we've got 2 FluentBits running. And that's capturing those log files and then sending them to CloudWatch. So let's take a look at the config map and the configuration of FluentBit. I'm going to click here on the copy command so that I don't have to type this real quick. But so what we're showing here is the config map, the FluentBit config map. And if you listen to the first section of this video, in the EKS console, when I went into the config map, I actually pulled up this same config
Mhm.
map. And so let's take a look at the FluentBit configuration here. First of all, I just want to say that the FluentBit config, relatively straightforward to read. I mean, there's definitely ways to make it very complex, and you can put a lot of stuff in the FluentBit config, but just right off the bat, to get your workload logs into CloudWatch, not too bad. We have 3 sections here.
Yeah, I
Input.
really like sorry to interrupt you there. I
No
really
worries.
like that they decided to go with this config map approach, which is so readable, so easy to configure and work with, as opposed to maybe having this all stuck into YAML somewhere. It
Yes.
really is nice. Yeah.
Yeah, absolutely. Let's just highlight. There's 3 sections here. There's input, there's a filter, right? And there's output. Let's guess what input does. Input is where the logs are and where they're being ingested from, right? So we can see here the path on the node that those container logs are. So they're on var log container slash, their .log files. There's a buffer here, and if you go to the best practices guide, you can see that there's some best practices around the configuration of FluentBit, especially around this buffer, right? So FluentBit is continuously tailing and buffering the log statements or the log files that are on the node, and then filtering them based on this filter. So we have log statements that are filtered matching the cube dot filter. Bit, because it's part of the CNCF, has some native Kubernetes understanding. So we have K8's logging parser and excluder already turned on, and that's a same set of defaults that add metadata around Kubernetes metadata to the log statements, and we'll take a look at that in just a second, what that looks like. And then we have an output. We have an output called CloudWatch, and we have a log group name, which is worker FluentBit logs. You can make this whatever you want. The region, and then the stream prefix, which you'll see when we dig into the logs in CloudWatch. So with these 3 sections, pretty straightforward. You're gonna get the workload pod, your pod logs to this CloudWatch log group. Boom, done. Right? So let's take a look at what that looks like. So let's verify that those logs are there. So like you mentioned, Sai, for often folks just use the kubectl log command to take a look at what the logs are. So we're going to take a look at some of the logs here of our application, and then we're going to go over to CloudWatch and see what it looks like over there. So I'm going to clear this out.
Very
Oh,
quickly, and Nirmal, I just wanted to ask, so there's probably some sort of IAM role or policy in place here that enables that cluster agent to communicate with CloudWatch, right? How is that set up?
Yeah, absolutely. So, like best practices that we recommend, we're using an URSA, so an IAM role for service account for FluentBit to be that has a policy that allows it to write to CloudWatch essentially, and that service account role that policy is attached to an IAM role, and that IAM role is attached to a Kubernetes service account, and
Mhm.
that Kubernetes service account is attached to FluentBit. I
Hence,
can I
IAM
can go
role.
into that. What's that?
Hence, it's a AWS IAM role for a Kubernetes service
Service
account.
account. Yes.
IAM role for service account. URSA.
Ursa, yes. And likely we're going to have a video on the security module where that goes into a little bit more details around what those are. All right, so we have our checkout pod for this shop, this watch shop. So we have this watch shop, the sample application, and we have some logs here for checking out, right? So awesome. We've got some log statements here. Let's switch over to the log groups in CloudWatch. So we're going to go back to our CloudWatch console. We're going to click on log groups. And if we remember in the FluentBit configuration, the log group was configured as the worker slash fluent or dash FluentBit, etc. So we're going to click on that log group, and we can see the log streams. And you can see that the log streams have the FluentBit dash appended to it.
Right, that prefix we
Prefix.
configured in the config. That's right.
Correct. And so the next thing we're going to do is we're going to find our pod, the one that we're interested in, which is the checkout. So we're going to search for checkout here, and we can see all the checkout pod log streams. So you can see that here we have FluentBit -cube, and then containers, and then dot the pod name. So we can see that this is the pod name. There's the checkout service has two pods. There's the checkout, and then there's the Redis. So let's take a look at that log stream. And here we go. Here we have some of the log statements. We can see the enrichment that FluentBit does. We have here the Kubernetes section of metadata, and we can see the annotations on that container. We can see the container name, the image. We can see the labels. We can see the pod name right here. So there's a lot of rich information, metadata that FluentBit adds to each log statement. And then we have the actual log statement right here, right? So this matches what we had right over here, right? So we have some get metrics log statements, right? So this is our scraper, our Prometheus A dot scraping the /metrics endpoint. And we have log statements for each one of those occurrences. And then if we go into the CloudWatch, we can see that same log statement right here. All right. So like moving on, we just to kind of recap, we went through the control plane logs. We did some digging into which services, which parts, components of our cluster are hitting the API server the most, right? We enabled and ran FluentBit with a configuration to capture pod logs from the node and send them to CloudWatch. And then we dug into the CloudWatch logs to actually see your pod logs so that you have information about what's going on in your application.
Okay, yeah, and when we talk about observability, there's two big terms that are always going hand in hand with it. It's logging and monitoring.
Monitoring, yes,
And
monitoring.
so
It's
I
core.
think that's what
Yeah,
we're getting into next here, right?
yes. So monitoring and metrics,
Right.
and this is important. This is not something that is in the EKS workshop yet, but maybe something in the future. Logs are one thing, metrics are another thing, traces are another thing. The real value comes from being able to correlate these pieces of information. So, like I mentioned in the beginning, we represent two different ways of doing this. The first one is our open source observability services, mainly around ADOT and AMP. So let's just dig right into it. So I've been mentioning OpenTelemetry. You asked me about OpenTelemetry earlier today. What is it, right? So we've got Open Telemetry project. I'm just going to click on this link so that people can kind of see what the logo looks like and what it is. Open Telemetry is the second most active CNCF project behind Kubernetes last year.
Okay.
So it's Kubernetes, Open Telemetry, and Prometheus are the most active communities and projects in the CNCF. And that shows you how important the importance of observability in the community and the attention that observability tooling is getting. Everyone wants to have this one tool agent that can collect all different types of telemetry data and send it to all types of ends or destinations to collect and to display that information and to analyze it. And so OpenTelemetry is striving to become that one standards-based agent and tool to collect all different types of telemetry. Today, it collects traces, and metrics. There is a log spec, and logging will likely be GA'd by sometime this year and make its way into AWS distro for OpenTelemetry in 2024, most likely. And so once logging is there, that means that the three typical telemetry data types are going to be, you can use OpenTelemetry to collect all those. So like we mentioned, we have an AWS distro for OpenTelemetry. More information here. We can put links down below on there. There's a link in the workshop as well. And this is our supported version of OpenTelemetry, this agent. The way that we're going to deploy it, or the way that we have it deployed in the environment, in our EKS workshop environment, is through the AWS EKS Manage add-on. EKS is a group of managed add-ons, and the OpenTelemetry collector or operator is one of them. So we have that enabled on the cluster, and what that does is it deploys a operator on the control plane, and that provides a CR. There's a CRD for an OpenTelemetry collector. The collector is the thing that's actually doing the collecting. Shocker in the name.
Of using this operator model is that instead of having to manage each individual collector pod and making sure they're deployed on the nodes and all of the good things that go with managing workloads, you just let this operator handle it. It's going to take care of the heavy lift for you and make sure that the agents, the collectors are running in the right place at the right time, right?
Yep, absolutely. So let's look into what that looks like, right? So this operator is running and it's waiting for CRs, these OpenTelemetry collector CRs. And those CRs are going to define the configuration of that collector. So the first step here is those CRs, those collectors need to have a role in the cluster that allows it to look, to capture the resources and definitions and the state of the cluster. So we're giving it RBAC policy that allows it to look at the overall cluster metadata. There's like we mentioned for the Fluent bit, there's an OSO and URSA, an IAM role for service accounts for the collector that in this case will allow it to write to Prometheus, the AMP workspace that we have. And then the other collector that we're going to run in the next section will allow it to write to Container Insights to CloudWatch.
So one question folks might have here, Nirmal, is that we've got this open source OpenTelemetry agent, and you showed us their site. It's great. In fact, just above here, you showed all the permissions that this thing requires, and of course, observability agents need a lot of permissions because you need to be able to see and record data from everything in your cluster. And so this is an important thing for folks to make sure that this is secure. There's no,
surprises.
Yes. Yeah. Right. Exactly. And being open source actually gives people a little bit of faith in the process. A lot of folks have looked at it across industries, but at the same time, I feel like the fact that it's open source is also why we felt the need to create our own distribution, right? Much like the Amazon EKS distro, which is also Kubernetes conformant based on the upstream Kubernetes. It's basically just Kubernetes, but we package it, support it, and critically solve security vulnerabilities. Is that the same idea here with ADOT, the AWS distro for OpenTelemetry?
Absolutely. You're spot on. When observability is, like I mentioned, is critical to understanding the state of your system, And the state of your system includes not only the performance and health of your cluster and your workloads, but it also is oriented around, are you meeting your service level agreements? Is your cluster secure? Are there kind of other things going on? Visibility into what's happening. And so when you have such a critical foundational component of running a successful environment, that the tooling that supports that, right? So in this case, open telemetry, you want to have support for that. You want to make sure that that thing is stable, it's doing what you need it to do, and it's collecting the data that you need it to collect. And it, if there's any security vulnerabilities or performance issues, that you can contact someone to help you to fix those issues for you. And that's why you want a supported ADOT collector. You want to support around your whole entire observability solution. It's super critical. All right, so we have an URSA here that allows it to write to AMP. That URSA is then attached to the service account that then is attached to this collector. I'm going to run this. I actually ran this earlier, so I'm not going to repeat this, but this command right here essentially configures a open telemetry collector custom resource, which then the operator deploys as a pod. And in this case, I believe it's a deployment. And let's take a look at what that looks like. So we're going to dig into what that collector CR looks like. And we can see here, we have this CR. And there's a lot of data here. Apologies. So we have this open telemetry collector CR. And there's a configuration for it. So we have here the spec and the configuration. And here we have the open telemetry piece of this collector. And open telemetry, kind of like FluentBit, has 3 components. And I'm going to run another command to kind of just highlight just the configuration of open telemetry so we can just dig into that. So there's not all this extraneous information. Perfect.
Nice.
So what we have here is the open telemetry collector configuration. And what's interesting about this, and I like to do this with customers, is I'm actually going to start at the bottom and then work our way up because it makes a little bit more sense that way. The first thing here is pipelines. Pipelines are is the way to configure open telemetry with its receivers, the processing it needs to do, and the exporters of telemetry data. And so what we can see here is we have one pipeline, and it's called metrics. And this pipeline has 2 pieces to it. It has a receiver and an exporter. It can also have a processor, which, just like FluentBit, could be filtering information. It could be adding metadata. It can reconfigure or change information before it goes to the exporter. But in this case, we don't have one of those. We just have a receiver and exporter. Our receiver is Prometheus, which makes sense. And our exporter is Prometheus Remote Write, which also makes sense. So we have a receiver here that the collector is expecting, or we're configuring it to scrape Prometheus metric endpoints. And then we're asking it to export that using the Prometheus Remote Write component to an AMP workspace. So let's dig into these components, the receivers and exporters, real quick. So we have here, I'll stick with our going from bottom to up. We have our exporter here. So we have our Prometheus Remote Write, and we have an AMP endpoint that's configured here that it's going to write to. Perfect.
Okay.
Makes total sense, right? So I know that this has like this AMP endpoint here, but we're going to show what that looks like in just a second. But we have a URL here that's the AMP workspace remote write URL. And we're configuring this exporter to write telemetry data to that URL. And then we have the Prometheus receiver. If anyone here has done any kind of Prometheus server configuration, there's this thing called the scrape config, or the Prometheus server config. This is essentially the same thing. If you're not familiar with it, this is a Prometheus server configuration, essentially, where we have the scrape interval, right? So remember, we looked at the logs for checkout, and we saw that the metrics endpoint was being scraped every 60 seconds, every minute. Here's that scrape interval right there.
Mm.
And then we have our scrape config. And our scrape config is we're telling the Prometheus component of OpenTelemetry collector, these are the endpoints, these are the Prometheus endpoints we want you to reach out to and grab and scrape and grab metrics from every 60 seconds. And this is a pretty standard Kubernetes Prometheus scrape config that we have here. And that is reaching out to different components of the Kubernetes system cluster. For example, the Kubernetes kubelet, the Kubernetes pods, and other components. So there's a bunch of others. And scraping those metrics and then doing a Prometheus remote write, just like the exporter is configured to send those Prometheus metrics to an AMP instance. I hope that's pretty straightforward. I think it is. There's more details in the lab about what these components are and links to what those components, the definition of those components. But let's just keep moving. We'll show that the collector is running.
So I guess the piece that I wanted to clarify was that we're not actually running Prometheus in cluster. We're connecting it to a dedicated managed instance of Prometheus running in AWS, right?
Correct. Yeah. In this instance, the OpenTelemetry collector is running a Prometheus style server that's configured with that scrape config, collecting metrics from those endpoints, and then using the Prometheus remote write tool to remote write those metrics to an AMP workspace that we have deployed as part of the workshop, which is the exact next step, right? So we have here storing metrics with AMP. Let's look at what AMP looks like in the AWS console. So we have here is the Amazon managed service for Prometheus AWS console page. And we have here is the EKS workshop AMP workspace. So I'll look at this workspace and we can see how this is configured. We have an active workspace, and there's two important kind of pieces of information here for the most part, which one is the remote write URL. So that environment variable in that OpenTelemetry collector that I just showed will get filled with this URL. And then this is that remote write API endpoint or URL that the collector is going to send Prometheus metrics to. And then later, when we're going into the Grafana dashboard, this is the URL that the Grafana dashboard is hitting to query and get information from the Prometheus instance. This is a fully managed Prometheus server instance, fully managed by AWS. So it's not running on the cluster. You don't have to worry about upgrading it, scaling it, etc. This is a fully managed server that is conformant to the Prometheus specifications. All right. So the next part here is digging into, let's take a look at what metrics we've collected, right? So we've got this collector running for a little bit in the environment. In the lab, we've got a Grafana instance running. So we're going to enable that. So I've got an egress or an ingress ALB for that Grafana instance. I've already got it up and running. There's some commands here to get the username and password for that Grafana instance. I've already got it configured in this demonstration, but when you're running this in your own environment, you're going to have to run these commands to get the username and password. And then you can go to that ingress URL and you'll get the Grafana console. And let me just show you what that looks like from the main view. So you're going to see something like this when you first log in. And we're going to just real quick go to data sources and show that this Grafana instance is connected to that workspace that I just showed you. This Grafana instance is pointed to AMP for its metrics. And we're going to open up the workshop dashboard that we have included, which is called the Kubernetes Cluster Monitoring. So that's this part of the lab. Let's just kind of explore this real quick. We have a very simple dashboard here. Give you a quick idea of what you can find out from the Prometheus metrics that we're collecting, and kind of give you an overall view of the health of the cluster. So we have here is like network pressure, input IO. We've got the cluster memory usage, right? So right now we're only using 26% of our cluster's total memory over all the nodes, and we're only using 3% of our CPU, right? So heavily underutilized, right, Sai? It's not a cost-effective cluster. We've got CPU usage. We've got the different pods networking, all the different pods, their memory usage, all the different containers, network usage, etc. So this is a quick way of kind of digging into the cluster, and kind of gives you an idea of what's possible with respect to Grafana and Prometheus and Open Telemetry Collector, ADOT Collector running on your cluster.
Excellent. And in this workshop, we're actually running Grafana in the cluster itself, but you could also use Amazon Managed Grafana and run it similarly to running Amazon Managed Prometheus in a dedicated place.
Correct.
So, Normal, I think one of the things that most folks will use this approach for is if they've got multiple clusters and they want to stream all of it into a singular, Prometheus and Grafana, visualize them in a single place. That's probably a good reason for running a managed instance rather than running it within a cluster, right?
Correct. Yeah. The idea here is that there is an operational overhead to running your observability tools, right? Whether it's the collector, Prometheus server, or a Grafana instance, there is some management and operational overhead as you have to deal with storage, configuration, upgrades, security patches, etc. It's cost effective to use the AWS managed services for that, especially when you're running multiple clusters, multiple environments, multiple different teams that need access. Maybe you need to separate specific types of data metrics for specific business units. You can quickly spin up multiple workspaces. You can set collectors to send Prometheus metrics from various clusters to one instance in different regions. You can have one environment that's just observability data, and you can send all your regions, all your accounts, cluster metrics to one AMP instance, for example, and then have like this awesome dashboard of all your clusters in your environment and the metrics that matter to you. There's lots of different ways and permutations to configure, and it's very flexible to do roll-ups, etc.
Makes sense.
Yeah. All right. So we've covered a very quick way to see open source observability services, Prometheus, AMP, Grafana, ADOT in your environment, collecting metrics for the different resources in your cluster. Let's switch to the AWS native way of looking at this data. So similar to the open source observability tooling, we're also going to use the ADOT Open Telemetry Collector to send metrics to CloudWatch, Container Insights. Lo and behold, Open Telemetry Collector, this one agent, right? So we're not having to change the operator model, right? So we still have that managed EKS add-on ADOT operator running. We're just going to reconfigure and deploy a different collector that's now going to send data to CloudWatch instead of an AMP instance. So let's get into it. Similar to what we have for the Open Telemetry Collector for the previous section, we have a cluster role here, and this is a Container Insights cluster role. It's very similar to the RBAC that that the OpenTelemetry Prometheus collector needs. We've also got an URSA. The URSA here has a policy that allows it to write to CloudWatch. Makes sense, instead of that AMP instance. And then we have that role attached to a service account, and that service account is going to be called, or is going to be attached to this new collector. So I'm going to go back to the console, and I'm going to switch from the existing collector, right? So we have this collector that we had running for the AMP instance, and we're going to switch it to a different collector that's for Container Insights. The way we set up these labs is there's a reset that we have specified between each lab. I'm not running that here because I don't want to, I don't necessarily need to reset the environment.
Yeah.
So here we have this new collector running as a daemon set this time instead of just a deployment. And let's look at what the configuration is. So similar to how we went into the configuration of the previous collector, let's take a look at this collector. Again, bottom to top, let's look at this pipeline. We can see that this pipeline is a little bit different. We have receiver, and now the receiver is AWS Container Insights receiver. It's not a Prometheus receiver anymore. So this is not doing Prometheus metric scraping. It's using the Container Insights receiver to collect metrics from the cluster.
So actually a question on that. So it's still getting the same type of data, right? It's the data that's being pulled is the same. It's just the way that the data is being, massaged and sent to, the receiver is different.
Correct. So it's also a different model, right? We have a daemon set here, and it's not necessarily scraping the same metrics. It could be getting those metrics by directly calling the API server, for example, and collecting the metrics that way. These are so the ADOT operator and collector are open source, and I believe there's links in the lab, and also we can potentially link to more resources around that, but you can dig into exactly what these kind of components are doing. We have here the AWS Container Insights receiver, which is doing its own way of collecting those types of metrics, similar metrics, but again, in a different format. We have a batch processor here, which is a way of collecting, like locally collecting in the collector. Oh man, how many times can I say collector in one sentence, right? So this is batching metrics in the collector and then having a batch of those together and then sending them out to AWS CloudWatch Container Insights as AWS EMF extended metrics format type data, right?
Right.
So this is totally different than what we just saw, right? Before we saw Prometheus style, metrics being scraped. We had no processor, and then it was using the Prometheus remote write to write to an AMP instance. This is completely different. This is using the Container Insights receiver. It's doing some batching of metrics, and then it's using the AWS EMF exporter to send it to CloudWatch.
So this really demonstrates the power of this ADOT collector.
Yes.
So this particular support completely changes the way this data is being scraped and collected and sent and everything, every part of that life cycle. So I'm guessing we contributed that upstream to the telemetry piece. And then, of course, that comes downstream to us in the AWS distro for OpenTelemetry.
Correct. I can't go into all the different types of receivers and exporters, but there's a lot. And we can definitely link to some of the best practices and some of the configuration elements and open source upstream components. So there's a lot of flexibility in this configuration. And nothing's stopping us from having both of those pipelines, right? So we had that previous pipeline sending to Prometheus. We have a pipeline here sending to CloudWatch. You can define multiple pipelines. So we could have one collector that's doing all the above, right? Whether that's the best way to do it, I'm not sure, but there's a lot of flexibility here. Let's quickly go right into that exporter, right? So we have the exporter here showing a log group and a log stream based on the node and the cluster name for that AWS EMF data. We have all the dimensions here, so we can see node CPU, we can see pod, CPU memory. Different metrics are being sent over EMF style in the EMF format with this exporter. We have a batch here, so we have a timeout, which is 60 seconds. So we're batching 60 seconds worth of metrics as in this processor. And then we have an AWS Container Insights receiver. Look how much lack of configuration there is here, right? So you essentially just have to enable this, and it just starts collecting this EKS data, right? So that's really awesome. Cool. And that's something that you can get with that upstream with this receiver, but also we have like default configurations in the ADOT collector. So awesome. Let's dig into what that looks like in CloudWatch. So, well, first let's just confirm that the collector is running as a daemon set. Here they are. So I didn't turn off the other collector, so that one sending to AMP is still going. But now we have a daemon set across the 3 nodes, setting the EMF formatted metrics. Next step, let's go into Container Insights. So we have here is CloudWatch. We're going to go right down here to Container Insights. The next thing we're going to do is we're going to go to Performance Monitoring. All right. So we have here is the EKS workshop. And lo and behold, we've got some metrics running here. As you can see, there's a gap here because I just re-enabled this collector. But you can kind of see right here is we're starting to get data while we were talking about the configuration of it. You can see CPU utilization, network traffic. Let me expand this out just a little bit. And we can also dig into the cluster. We can look into the pods, for example. So we have here's all the pods. Let's zoom in here. So we can see memory utilization of the different pods here. You have UI, carts, orders, catalog, checkout, KubeCost, etc. You can see all the container performance here in one view. You can do some sorts. You can filter. So let's take a look at that Star Wars pod. We have here is the different Star Wars pods that I've run over time. Obviously, not utilizing much memory or some CPU, etc. So you can sort by most recent. You can sort by memory, etc. So this provides a comprehensive CloudWatch native view into your EKS cluster, looking at the observability of your metrics.
Excellent.
Awesome.
2 different ways for us to get these insights from ADOT. I love it.
Yep. Last piece here is that we do have, it is EMF formatted data, and that means that it's being sent through CloudWatch logs. So we can also use log insights to dig into some of the data the metrics that we're collecting. Let's just do that real quick here. We're going to go to log insights again.
Yeah, this is very similar to the insights that we saw earlier.
Correct.
Query, but now we're doing it against the metrics collector from ADOT, not just the pod logs.
Correct. So we have here is EKS Workshop Performance. If we remember the EMF exporter, there's that configuration for where it's being sent. So we're gonna select that as the log group here, and we have a query here around node utilization, node CPU utilization. So we're gonna grab node CPU utilization, do some averages, and sort by node name. Now let's run this query, and here we go. So here we have the 3 nodes we have, and then the average CPU node utilization. And as you can see, highly underutilized. So we could probably turn these instance sizes down. But
I'm hitting it right now, right? And in our theoretical e-commerce retail sample app, maybe 100 people are hitting it every second.
Yeah.
So.
You never know. This watch app, maybe in the New Republic, they have a good galaxy-wide sale on watches, and this is the only Republic approved watch store in the galaxy, so you don't have to hire Han Solo to smuggle your watches. And all of a sudden our website gets real hot. Quintillion orders come in. We got to have that CPU ready, right, to make those orders.
Taylor set up for that. Auto scaling, we've got a dedicated module for that. Won't be covering it in today's episode, but keep an eye out for a next Containers from the Couch episode covering
auto scaling.
Yeah. Awesome. Well, that goes right into our last section today, which is cost visibility, right? With KubeCost. This is something a lot of our customers are asking about. We want to make sure that you are using you're optimally using our AWS EKS resources, your resources, in the most effective manner. And so let's go right into the section, cost visibility with KubeCost.
Yep.
So
Optimization is such an important thing for us and our customers. We want to make sure that you're getting the most use out of your instances. And the current native support for cost working with Amazon EKS is going to give you some information. It's going to give you the node level data. If you're using Fargate, you can even get native pod level data costing out of the cluster. I'll have a link to a blog I wrote last year that covers the Fargate use case there. But for really Kubernetes native insights, a lot of our customers are turning to this partner solution, KubeCost. And as part of that partnership, we've actually got a free version of KubeCost available and supported for our customers, allowing you to see this cost visibility data for single clusters. I believe there's a restriction on how far back the data is collected, but a great way to get started in optimizing cluster costs for totally free.
absolutely. And KubeCost is built on the open source OpenCost CNCF project. If you want to know more detail, check out KubeCost. And like you mentioned, Sai, we have a managed EKS add-on for KubeCost. So it's essentially one click on installation, and KubeCost can be up and running in your environment. In this case, we have it already running in our EKS environment. So let's just confirm that it's up and running. So we're gonna take a look at the KubeCost namespace, and we can see that the KubeCost components are there. There's a cost analyzer, kube state metrics, and a Prometheus server that KubeCost runs on. And in order to look at the KubeCost UI, we're going to do a quick port forward in our Cloud9 environment so that we can dig into what KubeCost can show us. So I'm going to run this command that's port forwarding the KubeCost UI, and I'm going to pull that up. All right, so let me pull this over. Actually, I can pop this out. There we go. I love the Cloud9 interface and like this integration here with the port forwarding. Everything's super, super nice. Check that out. So, all right, we have our KubeCost dashboard here, and we can see our overall cost efficiency, not great at 8%.
It looks a lot like our utilization number.
Yeah, look at that. I would say if you average these numbers out, I would say that looks like about 8, correct?
Yep.
So not a shocker there. We're burning through that money today. Let's take a look at the cost allocation. What's nice here is you can kind of dig into different filters here. So KubeCost allows you to tie specific CPU or different resource costs to different Kubernetes resources, such as pods, deployments, namespaces, etc. And you can filter that here. We can take a look at our Star Wars namespace, right? So let's add that filter. Look at that. It's free. It's not using much, so it's there's not much of a charge of that. Let's look at something a little bit more interesting. Maybe let's get rid of that label, and we can aggregate by, and this is done in the lab here. We can do an EKS workshop label here, so we can filter by label, and we can see all the components of our watch shop application here, right? So we have the UI, the catalog, the checkout, and we can see the CPU cost, the network cost, RAM cost, etc., and the total cost of each of these components. So typically, Sai, you have an application that consists of multiple microservices. Maybe you have different teams that are responsible for each of those microservices, right? So you have a UI team, you have a catalog team, and you want to do some chargeback within your organization, or you want to make sure that everyone's doing the most cost-effective way of standing up those services. This is a way for you to use KubeCost on labels, so you can label based on different teams etc. You can dig in, right? So we have our checkout service here, and we're digging in. We can see that, yesterday I was testing out this workshop, and it was a higher cost because I was doing more checkouts, and today not as many checkouts. We can dig into a specific time frame, etc. You can see the deployment here, and we can see over time the different pods. So we can go right to specific pods, right? So this is like really detailed
Right.
at that very granular level. So another view that's interesting is you can dig into a namespace and get an understanding of the cost efficiency of that namespace. So here we have the order service, and I drilled into it in KubeCost, and we can see that this is it's 17% efficient, right? Not great. And we can see some of the insights here on which components and of that order system deployment is more efficient or less efficient. We can look at some of the performance insights, right? So there's some potentially CPU throttling or out of memory eviction, risk level is high, and really dig into what we can do to save on costs. And you can actually click on this request sizing, where it runs a report on those services and gives some recommendations on right sizing the resources for this service based on the data that it has. So KubeCost is a great tool to dig into the utilization, the performance, and the cost efficiency of your cluster and the workloads that you have running. There's an additional section here highlighting that you can integrate KubeCost with AMP to have a single pane of glass with respect to a Grafana dashboard with not only the metrics and resources that we showed earlier, but also your cost and the KubeCost data all in one view. There's no steps for that right now within the workshop, but there is a link to a blog that provides guidance on how to do that integration between KubeCost and AMP. And with that, we've covered all of the current observability workshop modules, covering a large swath of everything from the EKS console view to logging to metrics in two different ways to cost utilization and observability.
Excellent. Nirmal, I couldn't have asked for a more detailed and thorough coverage of how customers can, set up observability for themselves successfully. I know still, even with this level of depth, we're just scratching the surface. Nirmal, is there anything specifically you want to leave with our users for how they can learn more? Maybe some links in the description that we can provide them.
Yes.
Any next steps for our viewers here?
Yeah, absolutely. So the first one is the Observability Best Practices Guide. So this is a new guide that was just published earlier this year. It's a AWS-wide Observability Best Practices Guide, and there's a section on EKS best practices, both AWS native and open source. And I want to kind of just quickly highlight, there's an essential metrics best practices guide, and we'll link to this below in the description for sure. EKS and Kubernetes provide so many metrics, and it can be hard to figure out which metrics are important. This is a best practices guide around that. The second thing I want to highlight is the Observability Accelerator. This is a EKS blueprints-based Terraform modules that provide a out-of-the-box AMP, AMG, ADOT experience on your cluster with defined Grafana dashboards that we've curated and created to provide a good comprehensive view of your cluster in Grafana. So it's all Terraform, it's EKS blueprints based. So you can run this in your environment and get a lot of what I just showed you up and running very quickly in your environment. And the last thing I want to highlight is keep a watch on Containers on the Couch, keep a watch on EKS newsletter, and keep a watch on the EKS workshop for additional modules in the future. And we'll be back. I'll be back here when there's new content, refreshing that content and digging in even more onto the observability picture.
Absolutely. The EKS workshop wouldn't have been possible without a number of contributors. And now that we're completely open source, we ask folks, if you want to get involved, if you want to add
particular modules, if you have even suggestions for us, please let us know. I'll have a link to the module, the workshop, the GitHub repo in the description below. Okay, with that, Nirmal, I want to thank you so much for joining us for this very detailed overview of observability, scraping and representing and visualizing all the kind of solutions we have in this ecosystem. Thanks for joining. And for our folks at home, be sure to subscribe and stay tuned for more episodes like this in the future.
Thank you so much, Sai, and may the observability force be with you.
And you. Thanks, folks.